Assalamu alaikum everyone. Hello. I welcome you all to today's webinar on integrity and HSE management of petrol stations in accordance with HSG 146, API RP 2005, and NFPA 30A using VAIL-PSRA software. My name is Saida Samia Aves, and I'm the lead software engineer at Velosi. For the next 2 hours, it will be our pleasure to host this webinar for you. Before we begin, if you can all please confirm that you are able to hear me clearly and see the slides by just typing in yes in the chat window so that we can receive the confirmation. Great. Also, please feel free to introduce yourself, your name, position, company, and which country you belong to using this chat window. It's really great to see an international audience of people from all industries and backgrounds. We would like to thank you all for joining us today, and we hope that by the end of this webinar, you will have gained good knowledge about the subject matter. So as some of you may know that this is our 60th webinar in the series of technical webinars that we are conducting. As a practice, we conduct one webinar every second Saturday. You can follow us on LinkedIn and make sure to check out our website to stay tuned to the latest updates. For the webinar recordings, you can subscribe to our YouTube channel, which is Velosi, so that you can receive our webinar recordings. So today we have quite an extensive topic, and we have an experienced panel of speakers today here for you. I'm with my colleagues, Mr. Ijazul Kareem Rao, Managing Director, Principal Integrity and Safety Consultant, Mr. Anthony James Williams, General Manager, Global Sales, Mr. Imran Saeed, he's the manager of RBI departments. During this webinar, we encourage you all to keep asking questions in order to clear any kind of doubts that may arise with time. This will not only help you, but also many others who can usually have the same kind of doubts. You can type in your queries in the Q&A window, and you will either receive a reply in the window or we'll answer it live. We'll try to answer in as much questions as possible during this session. We will have a detailed Q&A session after the completion of this topic. Kindly accept our apologies if your questions is not addressed. Due to the high volume of the questions that we usually receive, we have to be selective in this short span of time. We'll also be issuing a participation certificates to all those who have attended at least 80% of the webinar and have participated in the discussions through Q&A. Although most of us are in the comfort of our homes, it's Sunday, but some might be working, but we should be aware of the emergency exists that are around us. And due to the current COVID-19 situation and its emerging variants, we should be more careful, keep a safe distance, and in general, take care of ourselves and of those around us. So today's agenda includes introduction about our company, Velosi, the project objectives, scope of work, case study overview and results, and then we'll have a Q&A. So now I'll hand it over to Mr. Imran Saeed, who will start with today's topic.
Good day to all the participants who are basically attending this online session. So, as my colleague earlier stated, the today's topic is related to the integrity and HSE management of the petrol stations. So, the first part of the presentation that will be like introduction, like you can see this one, that technical part about the HSE management system for the petrol stations. So importance of the, just 1 minute, okay. Importance of integrity and HSE management in oil and gas industry. Ensure that infrastructure, facilities and equipment are working correctly and efficiently without jeopardizing employees and asset safety or negative impacting the environment. So like the other HSE studies and like the risk assessment, overall purpose is like we have to ensure the safety for the people, the environment and the capital, the assets. Then it promotes the protection of the environment that may be harmed by the growth of the petroleum operation and strive for continual improvement in the efficiency with which natural resources and energy are used. The overall objectives are summarized as below, like they demonstrate compliance with the HSE regulations and the standards. A streamlined prevention plan for major accidents and HSE management systems are in place. Health and safety hazards and environmental impacts have been identified, recorded, and assessed. Environmental impact and risks are being managed. Suitable measures have been identified and the critical equipment and the system are in place. On-site and off-site emergency plan have been drawn up. The risk of the project objectives are the LR as low as reasonably practicable. So first, if you will see this one, as the first step, we need to identify the hazards, then we need to evaluate the risk, and then accordingly, what mitigation measures are the process are in place to reduce the risk to a LARP level, which is basically as low as reasonably practicable. So this is the overall objective, and a sound overall plan is in place to safeguard life, property, and the environment and the business. So we will give you like the first these slides as a background, like why these studies were, you can say that carried out as a background. There were some incidents which have occurred across the globe. So we are just giving a few examples here. So first incident that was a Kachraka explosion that occurred, which is situated in the Russia, and accident. If you will see this one, like on a petrol station, there was a fire, and due to this fire, the 3 fatalities. So you can say there were the 3 people who lost their life, and after that, once this incident occurred, after that one the root cause was carried out, and as a result of the root cause, it was observed that the cause is LPG leak. The leak gas reached the hot exhaust of the pipe of the car, which caused the explosion. So you will see this one. So basically, as we all are aware that when some of the petrol stations are near to in the city where the lot of people are living. So in order to ensure the safety of the people, environment, because these are the area where any leakage can cause explosion, which can ultimately will be people who are living surrounding by, they will be injured or some can lose their life. Second incident was also we are giving an example, which was also in the Russia in Volgograd in August 2020, where 13 people were injured, but fortunately no one casualty was reported. And after the incident, when the investigation was carried out, the cause found was the fire was believed to have been sparked by a discharge of static electricity as fuel was pumped from a tanker to an underground storage tank. So in our coming slide, we will also give you the idea about what assets are covered under the petrol station. So one of the reasons was for this, the fire was due to the sparked by a discharge of static electricity. Another incident, these are some pictures for that one, if you will see. Now, if we will implement these studies, these HSE and integrated management system, what benefit that will be that we can achieve, which are summarized as below. These are not all, but few ones ensure the well-being of all employees, identify the potential HSE risk, identify measures to deal with these risks, minimize risk of unnecessary downtime, reduce costs associated with the accidents and incidents, avoid preventable injuries, prevent environmental disaster. As we explained earlier, the steps are first we need to identify the hazards we need to evaluate these hazards, which is called the risk, and then ultimately what we can get, we can reduce the risk, the costs associated with the accident and incidents. Uh, there are the different reference standards that are used in order to carry out these studies, which are listed here, like NFPA 30A, HSE 146, which is basically the main, these two, NFPA 30A, Code for Motor Fuel Dispensing Facilities and Repair Garages, and HSE 146, assessing and controlling the risk of a fire and explosion at site where petrol is stored and dispensed as a fuel. Then the APA-ERP 2005, and then in order to evaluate, because at the petrol station there are the storage tanks, associated piping, then in order to identify the risk, the damage mechanism, and performing the risk assessment, the standard associated with these, like the risk assessment study, which are like 571, 580, 581. Then because in the petrol station there are the underground facilities, underground storage system, the APA-ERP 1615 for these, APA-ERP 1621, 1631, then for the underground piping and the storage tank, to avoid the external protection, SCP systems are installed, and that for that one, APA-ERP 1632, then the management of underground petroleum system, APA-ERP 1635. So these are the different NFPA, HSE, and APA-ERP standards which are used for studies, and then the different standard like for the piping, pipelines, British standards, IP standard, ISBN standard, NACE standards, which is like the acronym of the NACE RP 10619, control of corrosion on underground and submerged metallic piping system. So these are the some reference documents that are normally used for the implementation of the such studies. They have been described here. So as mentioned earlier, so basically the main standard which will be used for the petrol station risk assessment and the risk assessment management is HSG 146. So if you will see this one, like we just give the overview of these standards, like provide guidance on assessing the risk, identify the necessary and controlled measures for the safe operation of the site where petrol is stored and dispensed for the use as fuel for motor vehicles and similar machinery. It sets out the steps to be taken to control the risk of the fire and explosion. The standard applies to the petrol filling stations, farms, commercial good vehicle depots, private business, marines, safety homes, and premises where the petrol is kept as a fuel. May be relevant to the diesel fuel where it is stored with the petrol. So this is a table of the content. So like introduction, the hazard from petrol, general principle of the risk assessment for the storage and dispensing of the facilities. There are basically 5 steps for assessing the risk and identifying the essentials measure to control the hazards. Then the system of work, training, risk assessment examples. These steps we will define in detail in our next, you can see the slide where we will present the case study. The other standard, the overview of the APA-ERP 2005, which provide the information and recommendation for the service station, facility, manager, which are like the employer, or designated site operator, employer, on the basic principles of the safety and fire protection. So the type of the service station operations covered full service, self-service, with or without repair base, car washes, convenience stores, food kiosks, and also truck stops and the quick loops. So these are the basic like the within a petrol station. There are the different items, are the different facilities. So it covers about the protection, that how we can protect these one. This standard is presented in two sections. Section 1, which is basically general service station, safety measures, addresses issues common to all type of the service stations operation. And then the section 2, which service station with repair bay operation, cover the unique concerns of the service station with these type of the operation. These are the content of this. Then the another standard, like the main NFPA 30A, which is basically code for the motor fuel dispensing facility and the repair gauges. This code shall apply to motor fuel dispensing facilities, marine motor fuel dispensing facilities, and motor fuel dispensing facilities located inside buildings, at fleet vehicle motor fuel facilities, and at farm and isolated construction site. This code shall also apply to motor vehicles repair gauges. This code shall not apply to those motor fuel dispensing facilities where only LPG gas, LNG, or compressed natural gas is dispensed as motor fuel. So these are the where it apply and where it is the asset which will not be covered under this standard. The table of the contents, if you will see this one, like the first chapter is about the administration, which tells about the scope, purpose, application. The next section is about the reference publication, then the third definition, then the storage of the liquid, then the piping which are used for the liquid from the storage facility to the dispensing machines, and then fuel dispensing system. What are the dispensing system and their requirement about the pump, submersible pump, requirement of dispensing hose, then the building, the next section. So electrical installation, operation requirement, vapor proceeding, and the vapor recovery system. So these are the different chapters which are covered under these standards. There will be some terms that will be used. So this slide gives us the abbreviation of those terms, like CUF, consequence of failure, CUI, corrosion-related insulation, GRP, that is material grass reinforced plastic, non-metallic material, MIC, microbiological induced corrosion. Then these are the non-destructive testing, MPT, magnetic particle testing, PUF, probability of the failure, SCC, sulfides, stress corrosion cracking, UGC, underground corrosion, and then the WFMPT, wet fluorescent magnetic particle testing. These are the different terms that will be used. Now we will go to the different definitions, just to give an overview to the people, so that this is what these definitions have been taken as per the NFPA 30A. So all of the listeners are maybe well aware about these definitions, but we will quickly go through so that that can be memorized and reminded. Above ground storage tank, a horizontal or vertical tank that is listed and intended for fixed installation without backfill above or below grade and is used within the scope of its approval or listing. Bulk plant or the terminal, that portion of a property where liquids are received by tank vessels, pipeline, tank car, or tank vehicle and are stored or blended in the bulk for purpose of distributing such liquids by tank vessel, pipeline, tank car, tank vehicle, portable tank, or container. Then the combustible liquid, any liquid that has a closed cup of flash point or above 100 degree Fahrenheit, which is 37.8 degree Celsius. So any liquid that has the flash point at or above 37.8 degrees Celsius. Container, like by definition, any vessel of the 60 US gallon, 227 liter or less capacity used for transportation storing of the liquid. Then the petrol station, the important term like the dispensing device. Overhead type, a dispensing device that consists of one or more individual units intended for the installation in conjunction with each other mounted above a dispensing area, typical within the service station, canopy structure, and are characterized by the use of an overhead hose reel. So this is basically the by definition. If we will go to the next definitions, fire resistant tank, any atmospheric above ground tank provided with the fire resistive protection for the tank structure and it sports from the exposure to a high intensity liquid pool fire, which is listed in accordance with the provision contained in UL 2080 standard for fire resistant tanks for flammable and combustion liquids are an equivalent standard. Flammable liquids are like any liquid that has a flash point below 37.8 degrees Celsius, that will be a flammable liquid. Then the fleet vehicle motor fuel dispensing facility. A motor fuel dispensing facility at a commercial, industrial, governmental, or manufacturing property where motor fuels are dispensed into the fuel tanks of motor vehicles that are used in connection with the business or operation of that property by person within the employee of such business or the operation. So these are the basically definitions, and we will just quickly go through. Then the gas, by the definition, a material that has a vapor pressure greater than 300 kilopascal absolute or 43.5 psia at 50 degrees Celsius is completely gaseous or is completely gaseous at 20 degrees Celsius at a standard pressure of 101.3 kilopascal, which is basically the 14.7 psia absolute pressure. Liquid, then the low melting point material, which are like the ductile materials such as aluminum, copper, brass, non-ductile materials such as cast iron, and rigid and non-rigid polymeric material such as plastic and fiberglass reinforced plastic that soften on exposure to the fire and that are partially or completely consumed by the fire. Then the marine motor fuel dispensing facility. Motor fuel dispensing facility at or adjacent to the shore, a pier, a wharf, or a floating dock where motor fuels are dispensed into the fuel tank of marine craft. And then the motor fuel dispensing facility, that portion of a property where motor fuels are stored and dispensed from fixed equipment into the fuel tank of motor vehicles or marine craft or into approved container, including all equipment used in connection therewith. A portable tank, any closed vessel that having liquid capacity of 60 US gallon or 227 liter and not intended for the fixed installation, including intermediate bulk container as defined and regulated by the US Government of Transportation. Then protected above ground tank, an atmospheric above ground tank provided with integral secondary containment, protection from the physical damage, and having insulation system intended to reduce the heat transfer to the primary tank when the tank is exposed to a high intensity liquid pool fire, which is listed in accordance with the standard like the UL 2085 standard for protected above ground tanks for flammable and combustible liquid are equivalent standard. The term like the safety can, an approved container of not more than 18.9 liter or the 5 gallon capacity, having a spring closing lid and spout cover and so designed that it will safely relieve internal pressure when subject to the fire exposure. And then the submersible pump, a pump that is located inside a storage tank and positioned near the bottom of the tank below the liquid level. So these are the different terms that are used as part of this subject which we are discussing today. These definition are just for your like the remind, so that you can remind. Then there are some definition which are used by the HSE 146, which because HSE 146 that will basically cover in more detail about the dispensing machine and their components, like the automatic safety nozzle, the check valve. Check valve is like a type of non-return valve which is used in the suction lines, which prevent petrol falling back from the line into the tank and so keep the system primed. Commissioning control valve. Console. A console is basically a control unit containing switches, keys, or similar items to control the operation and authorization of petrol dispensing on service station. Dipping, like checking the normally they will, whenever there will be a container at the level, the dipping term is used. So dipping, checking the level of the container of a tank by means of dipstick. Then the dispenser, which are like the metering pump, a measuring system designated to draw fuel from a supply tank and dispense it into the fuel tanks or approved container. Then the important definition, which is basically the double skin tank or the pipe double wall, which are basically used in order to store the fuel at the petrol stations. So by definition, these are double skin tank or the double valve. A storage tank, which is essentially a tank within a tank or pipe within a pipe with a small space between the two. This space is called the intersect, into which monitoring equipment can be fitted, a continual monitor for the leaks. So basically these are the double wall tank or the pipe where outside the tank or the pipe there is another pipe or the tank. Then in between the two there are the monitoring equipment are installed, which are basically the purpose is to check the leakage, if there will be any leakage from the main or inside the tank or pipe where the liquid is stored. Then the emergency cutoff switch, a switching device for quick operation in cases of emergency to disconnect the electrically supply of all dispensers in case of the emergency. That's the cutoff switch. Fail-safe overfill preventing device, like normally which is installed there. A device, a system designed to automatically shut off and prevent a delivery of fuel overfilling a tank beyond its maximum working capacity. So for every vessel there is a capacity. So this device is installed so that when the liquid is filled, it can automatically shut off the relevant parts. Fill point, the inlet through which the storage tank is filled from a road tanker. The filling station, premises at which petrol is sold to the public and is dispensed into the fuel tanks of the motor vehicles or into the container. The flame arrestor, a device fitted to the opening of a petrol tank, vent pipe to prevent flame entering the vent pipe and the tank. So these are basically the different parts which are installed at the filling station, and these are by definition. Then the hazard, anything that can cause harm. Hazardous area, an area where the flammable or explosive gas or vapor air gas mixture are may be expected to present in quantities which require special precautions to be taken against the risk of the ignition. So by definition, so I will just go through these definition quickly so that we will go now to our main. Then the risk, the likelihood that someone will be harmed by a hazard. Suction system, where the petrol is pumped from the storage tank by a pump fitted at the dispenser. Siphon system, the system of manifolding to undergo So a tank which automatically transfers fuel from one tank to the another until the liquid level is safe in the both. Used mainly with submerged pumping system. Under pump valve, if check valves that positioned under the dispenser in suction system, this position will provide early warning of the presence of leak. The vapor, gaseous material released from a liquid by evaporation. Vapor recovery system, a method of capturing petrol vapor during petrol transfer operation. Then the zone, basically in the fuel station, there are the different zones. The term normally used as a zone. By definition, the zone, the classified part of a hazardous area, representing the degree of likelihood of explosive gas-air mixture being present. So in the first part of the presentation, we just covered the theoretical portion, which is related to the basically the main standards which are used for this study, like NFPA, HSE 146 and APA 2005. Now we will go to our case study. There is now just quickly go through the one question. There one question for a petrol storage. Do we have double wall tank? If yes, what is the reason? So I think we have explained to you that double wall tank, basically they are used to store the petrol. The purpose is like the fuel that is stored into the main tank, and then as a layer of the protection, there is another layer of the protection, another tank or the pipe is or the tank is fitted. So fuel is stored inside the tank. If there will be any, you can say, the leakage, rather than coming out, that will be between the first tank to the boundary to the second tank, and there are some monitoring equipment are installed which can detect the leakage from the main primary tank. Then there is another question what is the difference between the incident and the accident? I think these are the terminology that are used. Incident, like where, because as per the HSE term, you can see that these are the accident when anything occurred. Incident, you can say that there are the possibility that can be occurred and how to mitigate them. The other question is like the difference. I think these questions, when we will go to our webinar, you will get the answer of the question, and if there, after that one, we will go into the question answer at the end. We did a case study, which is like the provision of consultancy services for HSE integrity study of petrol stations. So as an executive summary, yes, these are the bullets. These are like the information. We are not mentioning the reference where it was done, but it is like somewhere we did the manipulation so that when the main data will remain as it is. But we will give like what we did in the past as a part of the study. Like total 68 petrol stations were inspected and assessed in accordance with the regulatory authority, HSE 146, NFPA 30A, APA 2005, and APA 581 standards. As a first step, from the HSE assessment point of view, as safety environment point of view, the 40 petrol stations were classified in Group C and 20 were classified into the Group B. Similarly, as per APA 581, risk was assessed for all the like the static pressurized equipment and the associated piping. And then we observed that 45 petrol stations were classified as a medium risk ranking and 23 petrol stations as a medium or the low risk. By combining both SSG 146 group assessment and 581 risk ranking was undertaken following the completion of the field inspection and the review of collected documents. So here, basically, we also carried out the field inspection activities. Then, based on the field inspection activities, the hazard was identified, the risk was assessed. We prepare a formal checklist with the assigned score to assess the actual condition and compliance rating of each petrol station. During the field survey exercise, various number of the deficiencies were reported with a range from 10, with a minimum of 10 of petrol station A to petrol station B, which has 41 deficiencies. So based on the checklist, then you identified the deficiencies. A total 954 deficiencies were noted for privately owned petrol station, and 145 were observed for petrol station A owned petrol stations. On the average, 16 deficiencies were noted for each petrol station, and total 17 critical issues were also identified as a result of this study. So the purpose, as we have already discussed, like in order to avoid any accident, so that the people, the business, the environment, that would be safe and the risk would be as low as reasonably practicable, this study was carried out. Clients, in its larger effort to bring the petrol station operating in the country to the world-class standards, appointed Velosi to carry out an HSE integrity study of the existing petrol stations. So that the background or the case study introduction. The objective of this exercise was like to provide consultancy services for HSE and integrity study of the petrol stations across the country. Like someone, they basically asked about the HSE and integrity. HSE means that health and safety. We basically identify the hazards, then based on that hazard evaluation was carried out, and then from the HSE point of view, what precautions to be taken, that were addressed. From the integrity study point of view, because in the petrol station there are the fixed assets, like for the storage of the facilities, the tanks, then the associated piping. Then from the integrity point of view, what corrosion issues would be there, then how to manage these issues regarding either at the design phase or at the operation phase, by the inspections, by the installation of any other like a coating system. That was so these are basically two parts of the study. Then to undertake risk assessment and evaluation of the existing petrol stations, to identify any key improvements required in the safe operation of the petrol stations, to suggest remedial actions to achieve internationally accepted standards. These are the project objectives. The scope of study, like these are the some points as part of the scope, which are like survey of all the petrol stations listed by the country regulatory authority, identify remedial works required to ensure that all petrol stations meet the requirements of the regulatory authority standard document. Then, based on the review of the document, identify the shortcomings on the basis of the HSE 146, prepare individual report for each petrol stations, risk rank each petrol station on the basis of HSE 146, identify the optimum number of petrol stations required throughout the country. The approach that was used in order to carry out the study, that consists of these like the steps: site visit for the data collection and detailed visual inspection, categorization of the petrol stations with respect to the HSE 146 into the three category A, B, C. Then the semi-quantitative RBA assessment of the petrol station assets with normally the piping, tanks. The comparison of the HSE 146 and API 581 ranking. Then the development of the inspection guidance document for future inspection of the petrol station, adequacy of the number of petrol stations within the country, development and implementation of the petrol VAIL-PSRA. The study was carried out by using Velosi own software, PSRA, petrol station risk assessment, then the conclusion and the recommendations. So, same like if you will see this one, the same step they are defined into the like this flow chart. HSE integrity study of the petrol station. So as a first step, like Velosi assessment of regulatory petrol station using regulatory authority standard as a guidance. Benchmarking with the HSE 146, the criteria which is given, then the benchmarking. Site visit of all petrol station, then in a site visit, interviews were carried out, discussion with the petrol station management, review of engineering, maintenance and the layout plans. Then based on these engineering, inspection and maintenance document, verification was carried out to confirm the compliance with reference to the NFPA 30A, IP15 and APA standards. Then the review of the operating manuals. The purpose is the verifications to the compliance with the regulatory authority and the OSHA PSM order. As a result of all these steps, like the benchmarking, site visit, interview, review of the engineering, inspection, maintenance document, operating procedure manuals, then comparison with the OSHA, the carry out compliance, we have identified, you can say that these are the three steps, like identify the gaps in implementing HSE management, integrity HSE management system for each petrol station, carrying out the RBA study, then accordingly the proposed recommendation to ensure all petrol stations meet international acceptable standard, then the presentation of the detailed assessment report. So these are the basically the steps. So main 4 steps, like the review of the document, benchmarking, site visit, interview, review of the engineering document, inspection, maintenance, then performing the HSE and risk assessment, then like the verifications in with reference to the OSHA standards. The survey involved visit to there are 70 petrol stations, which include there are the 4 companies, company A 13, company B 7, company C 5, then a privately owned and the operator 42. There were the 3 petrol stations were under renovation and were not included in the assessment exercise. The documents that was collected with reference to the standard for the review to execute the study, like the engineering records, the reference of the review based on these engineering records, they were checked, reviewed in accordance with the requirement as stated in NFPA 146, APIRP 2005, NFPA 30A regulatory standards, QA/QC documents, operational guidelines and manual catalogs, inspection and maintenance policy, strategy, inspection and maintenance record, operators or the operation training records, the general information. From the different petrol stations within a different company, how many documents were collected, then they review, then based on these documents and after the review, their category was carried out as per the HSE 146, get into category A, B, and C with reference to the number of the deficiencies. So each petrol station was categorized like A, B, or C category. As part of the site visit and the visual inspection, a checklist was prepared, which consists of the following elements, and that was prepared as per the HSE 146 and National Regulatory Authority standards, covering the main 9 elements like the basic safety, offloading and venting, dispensing, storage tanks, pipe work, spill containment, personnel training, housekeeping, and the environmental impact. So these are the basically the 9 elements as part of the visual inspection or the visual like the checklist that should be minimum checked and covered. So if you will see this one, these were the basic safety, like the checklist was prepared and then the score was assigned, like from the basic safety point of view. Basic safety, there are the different questions, close and safe access from the road, safe exit, accept escape path, fire existence extinguisher provided, and then based upon there are the different type of the fire extinguishers which are type like the dry powder, foam, CO2, water. Then the based on these were checked their scores and then target score and the actual score. Then the next is like and for the fire either like in order to control the fire like the sand bucket provided, no open flame in the vicinity, potentially affected population flame, more than 100 meter, less than 10. So the checklists were prepared, then each point that have given it basically the score, and then the same was like populated into the whale plant software. So if you will see this one like the petrol station data wizard, like the throughput, population density was checked with respect to the plant, the petrol station layout. In the population density was checked, number of the people surrounding the area in that area, and then in the basic checklist like we discussed, like these are the main part and then their remarks were like mentioned. The major point like from the petrol station, first access from the road, either it is safe or not, escape path from the station, either it is available and it must be clear. Then from the fire extinguisher point of view, which type of the equipment are available and what is their condition and when in the past they were checked. So accordingly, their details was mentioned and put into the like in the system. So if you will see this one, first like the different part offload and venting, basic safety, then storage, dispensing, offsite facilities, environment, pipe system, training, comments. There are the different questions that were prepared and checklist was filled. The next, like the offload and the venting. In the offloading and the venting, like these are the as part of the checklist, which are basically the reference. If you will see this one, the like the questionnaire which were prepared in order to check and their reference was mentioned, and these reference are like as per the HSG 146, NFPA 30A, and their clauses were mentioned. So from the offloading and venting, like the main part which are like dedicated tank access provided, forward tanker exit path, fill point clearly marked, fill point in a good condition, fill point close to dispenser, dispenser isolated during loading, fill point greater than 6 meters from boundary, overfill device, spill containment provided, and then the vent pipe height less 4 to 5, greater than 5. What will be the condition of the vent pipe? And then either the flame arrestor provided or not, pill cap provided with the captive devices or not, FFE near offloading. So all these points were checked for the offloading and their checklist was prepared, and each question has a like the score, and then based on the like the condition, the answers were provided. So second step, first step we discussed about the basic safety. Second, the checklist was prepared for offloading and venting. Third was prepared for the dispensing. Then from the dispensing, like as per the HSE 146 requirement, like like where the dispenser is installed in a safe location, greater than 4 meter from the side boundary, greater than the 6 meter, 9 meter, and then accordingly they are like check that one from the site survey that where it falls. Dispenser undamaged clearly marked route from the dispenser from and to dispenser. Dispenser provided with the safety barriers, nozzle and hoses in good conditions, volume time limit cutoff provided, breakaway occupied coupling provided. So all these were like the checked as per the HSE 140 HSE 146. So like the number of the dispenser at each petrol station was checked. Then against each dispenser, how many nozzles, then the number of the nozzles, and then where these nozzles were dispenser were installed. Then either the sand bucket, dispenser damaged or undamaged, clearly marked route around the dispenser, safety barrier provided or not, nozzle house, the condition, either they are in good condition or any problem, volume time, limit, cutoff, breakaway coupling. So these are the different checklists, and each question has like the score, and then the score were provided. Based on this number of the scores as per the HSE, then their category was or the risk ranking was carried out. The fourth is for the, if you will see this one on the like we will go into this slide, like you will see these are for storage, and even if you will see these one, these are the 9 element as per the HSE 146 that would be addressed, that need to be checked as part of this assessment, HSE integrity assessment, like the offloading and venting, basic safety. Now the third is the storage, and then next would be the dispensing, offsite facilities, environment, pipe work system, training and comments. So these are basically 9 elements that would be discussed. So now as part of the third element, like the fourth, storage. So from the storage, like the checklist was prepared, and then we check that either for the storage tank any inspection was carried out. What is the life of the storage facility, storage tank? 15 years, the less than 15 years, 25 years. Either the storage tanks are the double skin, yes or no. Overground tank, present or not. Stay away from the traffic side, physical protection. So based on this one, like these questions were checked, and they were populated into the VAIL software. For example, like this one, super capacity, LGO capacity, and from the storage, like any inspection was carried out, the live pressurized dispensing system, visible containment loss, ATG installed working, overground tank, close, double skin tank. So there are the double skin tank present, any leak monitoring system available, and what will be the health of that leak monitoring system. So then the next is the pipe work system, because from the storage to the dispenser, there is a pipe work. Then from the pipe work, we check either the pipes are the metallic pipeline or the non-metallic pipeline. What is the age of the pipeline? Either the single skin, visible containment loss from the pipe, and the checklist was prepared, which are with respect to first is the age of the piping system, then either they are the double skin or the single, and then if it is metallic, then either the pressure system, any incident or the loss of the containment observed. So these are the questionnaire that was prepared, or the checklist prepared as per the HSE 146 requirement. Then the next is the spill containment offsite facilities. So if you will see this one, spill and containment and offsite facilities can spill from the falling areas. So drainage system. So in this way, basically, there are systems, then there are the different like car wash, oil change area, warehouse, restaurant. So next is like the training. In the training, like the people and the employer who are working at there, like their training has been carried out with respect to the firefighting, with respect to the emergency shutdown procedure, with respect to the vehicle collision procedure, with respect to the safety loading procedure, spill management, safe dispensing operation procedure, safe management system. So these are the basically requirement as per the APA-ERP 2005. The training of the staff or the people who are like working at the petrol station, so that in case of any incident, they have the awareness that how to control this type of the risk. After the training, like the housekeeping, uh, that is also an important part as per these HSE and NFPA requirement, especially NFPA 30A class 9.2.7, that emphasize on the housekeeping, so that the as part of the housekeeping, we need to ensure that the access ways and the route maintenance area are the clear refuse. So housekeeping, then these are the different points from the housekeeping was checked, like the spill, warning signs are available, instruction we are the visible and they are in the good condition, spare overall available for the staff. The from the environment point of view, like the next is the environment, like where is a, for example, there is a, if they are using the car washing area, like there is a wastewater and that either wastewater treatment on site or off site is only car water used for car washing, waste car wash sent to either there is any system for the sending this wastewater to the sump, where is the car wash effluent stored, where is the car wash water disposed, quantity of the wastewater generated, where stored. So based on these one, because these are the like car washing area, like the wastewater where it is stored and where the treatment process is carried out. Then from the next element after the environment, the storage, like these are as per HSE one, like the we need to check the age of the tank. Then with respect to the numbers, their scores with respect to the age, less than 20 years, 20 to 30 years, greater than the 30 years. Then the about the tank, like either it is a single skin metallic, GRP or equivalent, or double skin without a constant monitoring device, double skin with a constant monitoring. So there are the different type, and then accordingly this scoreage, the overall rating is assigned. So if you will see this one, the like from the sitting of the tank, monitoring, like the consider means of monitoring tank content to detect leak, frequency of the dipping, need for the constant monitoring system, leak alarm system. So same like the storage, and this data was populated into the waste plant PSRA, then the score was assigned and accordingly the overall rating was carried out for this element. So the assessment approach as per the HSE 146, like the for the delivery and venting from the following table selected, like we need to tell that like the fill point located within the building, fill point located within approximately 4 meters of public thoroughfare, pavement shortcut, fill point located within the 6 meters. So here basically you can say this one, the area or the location is important where the petrol station and the dispenser are installed, and what is the distance in between. Then accordingly the rating was assigned, and based on the ratings, like the if you will see this one, like from this overall rating, if the points will be within a 3 to 10, then it will be in group A. If 11 to 24, group B. If more than that, then it will be to the group C. So these one like from the different perspectives, these questions like their distance, then from the like the tanker wholly or partly offsite when unloading, entry and or exits at the site is difficult for the tanker. So based on their like the storage, dipping, monitoring system, and entrance and the exit, based on these one, then the site features for the spin case of any spillage, the weighing factors are installed and then the overall rating is mentioned. Then the delivery and the venting, same we discussed, like based on that one, the stock data was populated into the whale plant against each component within for each petrol station. The assessment approach for the pipe work, the pipe work approach was carried out based on the life or the remaining life of the piping, like less than 20 years, 20 to 30, greater than 30 years. Higher numbers mean that one, it will be into the higher category where the more monitoring or inspection or the maintenance will be taken. Then from the construction point of view, if single skin metallic, single skin non-metallic, or the double skin with the constant monitoring between the skins. So you will see this one, the double skin with the constant monitoring, which is basically reliable, good, less score. So whereas single skin with the non-metallic and the single skin metallic. So based on these one and then the life and the type of the system, the score was assigned, and if the rating was carried out based on these scores. The assessment approach, these are like the from the like construction of the lines, from the leak monitoring system, there are the different components which are installed on the piping system, like the check valves, control measures, then the system of work, location of the dispensing equipment, improve visibility, and our supervision, incident control measures, fire separation measures. So these are the basic elements based on that which are used for the assessment. The pipe work, the top data after checking that one, the data was populated into the VAIL-PSRA to check the like the overall weightage, and then based on the overall weightage, the overall rating and the weightage and the questions as we discussed, like for this one, the age of the pipe, material of the construction, and type of the pipeline monitoring system. Then as per the HSE 146 assessment approach for the dispenser, there are the like first either the standard dispenser certified aspect to like electric pump with no standards. If there are the pump and they are certified with the SFA 302 standard, to score. If it is certified with BS 17117 or E and equivalent, then the one score. Then the sitting of vehicles, like the vehicles being refilled partly or wholly on the public highway in a building. 3. Vehicle being refueled have to reverse or negotiate to get a pump. 2. Vehicle being refueled will wholly on site and able to drive and safe and off-site easily. 1. And like the site condition, like whether it is within the building or under living accommodation, their conditions, or it is far away, then what is the distance, 4 meter, greater than 6 meter, 9 meter, then accordingly the score was assigned. And if the scores between the, so these are points which we basically checked as part of the visual inspection, review of the documents. Then accordingly score was assigned, and if the number of the score is between 8 to 10, then it will be in the category A. If 11 to 24 into the group B. If it is more than that one, then it means that increasing the hazard, which means the special, you can see that another, we need to take the precautionary measures. The same data was populated into the fair plant software PSRA. These are the basically risk assessment checklist as per the HSE 146. So these are the basically the same we discussed that were covered under this risk assessment checklist. These are basically different parts. The second is like a site visit and data. These are basically we basically provided you the approach how the HSE integrity assessment was carried out and their compliance with respect to HSE 146 and NFPA. So summary of the categorization, like grouping of each petrol station in terms of group A, B, or C is done based on the factors. So if you remember that one in the executive summary, we mentioned these categories. So this category of the group A, B is classified as per the as defined in HSE 146 for each product which is stored into the fuel station and associated facilities based on the safety layout, offloading and venting system, storage, pipe work, dispensing. So as part of the site visit, first we check that identification of the defect ball boards. So like you can say this one as we discussed, we need that from the housekeeping point of view and from the entrance and the exit path, we need to check that it will be like the safe, there will be no hindrance, and somewhere there is the abnormalities that have checked and reported, so like the identification on the defects. So these are the some these are the different defects that should not be there for the safety as part of the standard. Then the from the access and exit point of view, as we discussed that one, uh, access should be clear, entrance and the exit path should be clear. Then from the visual inspection result point of view, there are the different assets that was visually inspected. For example, dispenser, there were the 641 number of the dispenser was installed, and out of 641, 237 there were some defect noted, which are major issues like the provision of the breakaway, coupling, and pipe shear or dispensing unit. Then from the tanks, storage facilities, there are the 401 number of tanks, for 298 some defect observed. The tanks were basically in order to store the premium, super, LGO, and Caro. There are 143 tanks for the storage of the premium, and for 108 tank defect observed. Similarly, for 95 tanks, which are basically for the super tanks out of 130, 95 defect observed. So the defects are like automatic tank gauge, which are basically greater than 15 years old, do not have this feature. So the tanks somewhere which are 15 years, they did not have any automatic tank gauge system. So this was the major defect that was abnormality basically that was observed. Fill point and the vents out of 401 for 178, there were some minor defects or issues observed. And the major issue was like the no spillage containment control and no flame arrestor on the vent pipe. If you people observed that one, you remember that during our earlier discussion, as per NFPA, we mentioned that one, the flame arrestor should be present so that if there will be any flames, vapor that can be caught into the flame arrestor. Then the visual inspection, preparation of the visual inspection report. So we basically prepared visual inspection report with the help of then the data was populated into the PSRA inspection report, and then this the site survey they were using basically for in order to carry out the risk assessment. The steps like recording in the VAIL software, we already shown you, and in the next slide you will also get in more detail the recording of the engineering data, history, assessment as per the HSE 146 for the 9 element which we earlier discussed, recording of the visual inspection record, then the risk-based inspection including the assigning the probability of failure, consequence of the failure with respect to the applicable damage mechanism for each equipment and piping, future inspection planning, the risk matrix, then the capable of the comparison among regulatory authority ranking, HSE 146 and plus CRBI risk. Critical issues which were found, like the protection against the static charge. There were the 49 petrol stations where there is no protection against the static charge was provided for offloading operation. If you remember that one of the cause of the fire for one petrol station and the LPG at Russia, that was no protection was against the static charge, and due to the static charge, the explosion was occurred. That was a critical issue. Then the inaccessibility of the emergency cutoff switches. So these are like mandatory that if there will be any problem, the emergency cutoff switches, so that automatically system will be isolated, shut off. So emergency cutoff switches were inaccessible in 3 petrol stations. These switches were either more than 300 meters away from the offices, forecourt, or in place difficult to access for tanker drivers and site operators. So basically, they are far away from the facility where basically they should be installed, so that if there will be any emergency, the inaccessibility, that was basically finding. Then the flame arrestor at outlet vents. No flame arrestor were provided at the outlet vent. In 66 petrol station, absence of the flame arrestor is a potential of the fire explosion hazards. The safety barriers at 14 petrol station, collision barriers were not installed to avoid physical damage to the dispenser from a vehicle. Impact, the layout constraint, dedicated and clear tanker access is not provided in 11 petrol station. This can be a possible cause of accident during maneuvering of the tanker. Fill point marking, there are the 30 petrol stations where the fill point were either in the poor condition or not clearly marked. So these are the basically, you can say, the different reasons. If anyone who will compromise on any cause, any element, or any safety, then what will happen? There will be a chance. It's basically the hazards are there because the fuel is like a flammable material. Any safety measure, if it will bypass, then small leakage, small, you can say, ignorance, that can cause an accident, and the people who are working there are nearby, there will be the casualties, injuries, business will be affected, environment, there will be impact on the environment, reputation. So as part of the integrity and HSE, we need to take care each and every element as stated into the HSE 146 NFPA document. And these are the basically major findings. And if you see, these are the mine already mentioned into the standards, but we need to follow from the integrity point of view. The 7 was the fill point captive devices. No captive devices were mounted on the fill point in the 4 petrol stations. Also, rubber seals were missing and cap found loose at the time of survey. Absence of the captive devices can cause release of the fuel vapor in the nearby atmosphere. If you will see this one, any one, there is a chance of the hazard. Overfill devices, it was noted that overfill devices were not fitted on tanks at a 60 petrol station. Absence of overfill devices can cause fuel spillage at the time of offloading, thus creating loss of fuel and a possible fire hazard. Breakaway coupling at 24 petrol station, breakaway coupling were not provided and attached to the dispensing unit. This could lead to the spillage of fuel in the event of damage to the hose or nozzle. Location of the vents. Vents for the petrol stations, 4 petrol stations were not located at the safe location. They were either near new construction or in the middle of the market square, resulting in discharge of fume and exposure to the public. The vent discharge point should not be within the 3 meter in any direction of opening window, air conditioning unit, or the other operating to the other opening to the building. Single skin tanks, like normally there should be the double skin tank, but it was observed that 17 petrol station fuel storage tank were a single skin metallic construction. So if you people remember that in our previous slide when we were for the storage facilities, wherever there is a single skin, the highest number were given, and these highest will be leading to the criticality like the group B or the continuous monitoring. There is as such no inspection or leak testing record available at petrol station. Any leakage from the storage tank may lead to the potential fire when hydrocarbon is accumulated. Training, that was also an important part as we discussed. Like evidence of adequate training record for the staff was not available for 45 petrol stations. So we should provide the proper training to the people who are working at the petrol station so that they have the proper awareness that if there will be any, first of all, they should know about the layout, where there is, in case of any emergency switches are installed, automatic systems are installed, and how they need to behave in case of any emergency, and that should come into the training. So their training should be mandatory. And when we did this exercise, and we found that a lot of people there they did not have the training, or the evidence was not mentioned. So lack of training may lead to the mismanagement and mishandling of the petrol station operation, country regulation standards, addressing the training of the petrol station staff. Leak monitoring system, the leak detection system, so that if there will be any leak that can be detected, and accordingly system will be automatically shut off. And we observed that for 28 petrol station, a leak monitoring system, hydrocarbon leak detection system was not implemented. Through stock reconciliation system, absence of such system may lead to the potential fire explosion when hydrocarbon is accumulated. Automatic tank gauges for 39 petrol station, automatic tank gauges were not installed. Tanks which are filled via offset fill point should be provided with an automatic tank gauge instead of dipstick tube. So these should be like here. CP system, because there are the underground piping, underground tank. CP system should be there to avoid the external corrosion. That's basically a layer of protection. Like CP cathodic protection was not provided on a single skin underground tanks and pipe burst system at all petrol stations, and only coating was used to protect against the soil side corrosion. So from the soil side corrosion, basically one barrier is a coating, second barrier is a not the barrier, CP system, because the CP system will give you the health of the coating, like either the coating is in a good condition or not a good condition. It is the standard practice to have a CP system along with the external coating. That is basically the NACE requirement on new piping and the tank. That's for the buried tank and the piping system. Inspection and the maintenance record. Maintenance is being carried out by unlicensed technician in all private owned petrol stations. Most of the maintenance work is done on ad hoc basis and potentially in an unsafe manner. Furthermore, there was absolutely no previous maintenance and inspection records are available. In the absence of such record, past failure trends cannot be analyzed to make any future decision. Single skin pipe work system, we observed that for the 25 petrol station, there was a single skin metallic system piping was installed or constructed, and there is as such no inspection or leak testing record available at petrol station. Any leakage from the pipe work system may lead to the potential fire and explosion. So just I will give to my colleague for a few minutes. We will, the time is you can set short. We will go quickly so that we can cover based on these one, the risk ranking was carried out, and then the petrol station were categorized into the major category B and C. The criteria, as we discussed, was mentioned in 146 risk assessment. By considering all these 9 elements, the score was provided, and we observed that 28 petrol stations were in a group B and the 40 in a group C. Then the number of the deficiencies, percentage compliance for individual petrol station and critical issues are categorized like the group C. They were further classified into the priority 1 or priority 2 petrol station. Group B, which are further classified into the priority 3 or the priority 4 petrol stations. Like priority 1 was assigned to the petrol stations, which are in the group C, where we also carried out this ranking as per API RBI, where we have the medium or the medium high risk, and the number of the deficiency, there were the 20 deficiency, and a percentage compliance less than the 65% related critical issue were also considered while prioritizing. The 20 petrol stations were put into the priority 1. Uh, these are basically petrol station number 1, lowest compliance percentage, maximum number of deficiencies in this priority group, and the highest ranking as per API 581. For the priority 3 criteria, for the priority 2 criteria, for the priority 1, that we discussed. Then the criteria for the priority 2, which was assessed assigned to the petrol station in a group C, where as per API we have the risk medium high with less than 20 deficiencies. In the priority 1, we have more than 20 deficiencies, same risk. In the priority 2, with less than 20 deficiencies, and the percentage compliance are more than 65. For the priority 1, it was a less than 65, here more than 65, and there was a 20 petrol station in this group. Criteria for the priority 3 petrol stations, it was where as per the API RBI, the risk ranking was either the medium or the medium high, and the number of the deficiencies only reported less than 10, and the compliance more than 65%, and the 8 petrol stations were put into this category priority. Criteria for the priority 4, here basically the risk as per API RBI was the same, like a medium high, but as per HSE 146 group B, where the number of the deficiencies were between 5 to 10, and the percentage compliance is greater than 65. So 19 petrol stations were assigned with this priority. So this table basically like refer with reference to the priority 1, priority 2, priority 3, and the 4, and the applicable critical finding and recommendations that were mentioned with respect to the each petrol station. For the priority ranking, so the ranking as we discussed, priority 1, priority 2, 3, and 4, which are basically with respect to the risk almost was the same, medium high APRB, but the number of deficiencies. Greater than 20 deficiencies, priority 1. Less than 20, greater than 20 deficiencies, but the compliance less than 65. Second priority, number of deficiencies 20, but the compliance 65 or more than 65%. Priority 3, deficiencies 10, and you can say the compliance more than 65. Whereas for the priority 4, where the number of deficiencies were between 5 to 10, and the compliance more than 65%. So these are the bases and on which each petrol station was prioritized. So the compliance rating, like where we have the compliance 0 to 20%, they were in a red zone, poor. The requirement is not being compiled with in any way or format. There is no plan to implement it. 21 to 40% average below, 41 to 60 average, 61 to 80 above average, and more than 80% compliance. It was excellent. And then accordingly, the requirement the year was mentioned. So this is the overall like the summary with respect to these like the percentage of conformance and the conformance rating for the 4 facility A, B, C, and the privately owned. They were categorized into the poor, below average, average, above average, and excellent. So the compliance rating, they were summarized in their tabular form. Then for the assets, their risk assessment was also carried out as per API 581, and the assets which were covered like the storage tank, piping, and also the offloading points and venting and the dispenser. So as part of the RBI, like the steps which were carried out like collection and the review of documents, National Regulatory Authority, asset type, identification of the asset type where this study applies, review of the historical record, identification of the applicable failure mode, then the classification, then the PUF and CUF assessment, risk ranking, and the inspection plan or the inspection technique and the logistic requirement. And this study was carried out using VAIL-PSRA, Petrol Station Risk Assessment, Plant software, which is owned by the Velosi in-house software, certified with the SAP Exceeder. The 5x5 risk metrics were used, where with respect to the different component, their risk ranking. So red at the top, right at the top, that is for the high, then this orange color for the medium high, yellow for the medium, and green is the low. So the assets which are into the green and the yellow, they are like into the large risk, whereas which are in the orange and the red, where the inspection or the mitigation measure need to taken to bring the risk to the alarm. Safety risk matrix, then the environment risk matrix, business risk matrix, and then comparison was carried out between HSE 146 and API 581. So regulatory authority risk categorization is mainly driven by the consequence aspect. For example, both throughput, population density are focused on damage part. Probability of failures factors, which are like the age, condition, previous history, are not considered in this metric. So these are basically from the regulatory risk metric. HSE 146 is considering consequence and age of the asset as a group categorization. However, present condition or past history of asset is not being considered as used in API 581. So API 581 risk ranking is carried out on the both factor probability of the failure and the consequence, where both PUF and CF factor could be calculated both on quantitative or semi-quantitative aspects. So this is basically the comparison between the regulatory HSE 146 and API 581. So then for the different petrol station, their regulatory risk metrics, like based upon the regulatory risk metrics, where there is falls based on the HSE grouping, HSE 146 between the group A, B, and C, where they fall, and based upon the API 581 risk ranking. After the risk ranking, the next was the inspection planning. Inspection planning was done based on the aspect like the what to inspect, why to inspect, how to inspect, where to inspect, and when to inspect, where based on the applicable damage failure mode for these assets, the inspection technique, their locations, and the time was identified. What to inspect, that is basically the petrol station, and in the asset that was covered like petrol storage tank, pipe work, dispenser, delivery point, and venting, which require maintenance and inspection during their life cycle to assure that the asset will complete its design life. Why to inspect? There are the different failure modes which are associated with these components, like for example for the storage tank, general thinning and pitting. If there is insulation available outside the tank, then the corrosion under insulation. For the buried tank, underground corrosion. Then for the weld joint, corrosion of the weld joint. Then microbiological induced corrosion, stress corrosion, cracking, like the external leakage, fatigue, brittle fracture. Then for the pumps, there are the dispensing and the pumps, where failure mode would be like the suction cavitation, lack of fluid, reverse rotation, cyclic, coupling misalignment, imbalance, close head operation. How to inspect, like the different inspection techniques which were recommended, which include the visual inspection, ultrasonic thickness examination, gauging, magnetic particle testing or wet fluorescent magnetic particle testing. Then where to inspect, like these are the for a one tank, like the not the exact but reference drawing were prepared where with reference to like the locations were identified where the inspection to be carried out. Then when to inspect, with reference to the different inspection technique, their frequency was mentioned, like the element, the 9 which we covered. like basic safety, offloading and venting, dispensing, storage, fiber, spill containment, training, housekeeping. These are the basically 9, and 9 was the others. So all these 8 elements. When the visual inspection to be carried out, then the entity inspection, which is basically applicable on the offloading and venting, pipe work and the tank. External inspection, then the internal inspection for the tank when it needs to be carried out. So generic sketches of the plant inspection requirement has been developed for the SL, like for the storage tank, piping system, dispensing, offloading point and venting, where the like activities, what type of inspection to be carried out, either they will be on stream or we need to off stream, either external or internal, intrusive or non-intrusive, how many man hours are required, mechanical preference, HSE caution and the access. Then the reports were created, like each petrol station, the petrol, like the address, then the commissioning date, present date, number of tank, volume, HSE is the group, like which category, priority, and then API 581, this ranking and number of the nozzle, population density, the summary of the major findings, then the overall group rating, like for all the equipment type, dispensing, storage, delivery and venting, overall weightage, the rating, like the wherever if you will see the storage is come, they will be in a group A, group B. So like all these one with respect to the different product which are stored in like the same 90R diesel. Then from the API-RB assessment, the results or conclusion like the damage mechanism was assessed, then the risk ranking was carried out using VAIL-PSRA, and the asset that were covered that contains the storage tank, piper, dispenser, delivery point, venting point. The risk assessment was carried out considering the standard like API 571 to rectify the damage, and for piping inspection like 570, 580 and 81. The PUF assess based on the applicable damage mechanism, inspection effectiveness, previous inspection record. The CUF was assessed based on the nature of the product, throughput, production density of the petrol station and its surrounding. Finally, risk ranking of these equipment is done by combining the both PUF and the CUF, and their results are tabulated, mentioned in this tabular form, tabulated like different component, equipment type, like what will be the dominant damage mechanism, then based on this one, what will be the PUF, CUF overall risk ranking. Then from the inspection finding, we prepared the checklist based on the API-RP 2005, which we earlier explained into our slide that what points were covered in these checklists for all the 8 or 9 elements, which are like the basic safety, and which include like clear and safe access, safe exit, escape path, emergency cut-off switch, available or not, dry fire extinguisher from the dry powders, foam fire, CO2. Then from the basic safety, like the positive points were also noted, and the areas for the improvement were also like water fire extinguisher were not provided, emergency contact number were not displayed, register of the dangerous was not maintained and available on site, incident investigation form was not available, appropriate measures for protection against static electricity were not adopted. Then for the offloading, there was a positive point and they were filled into the checklist, like the fill point were properly marked, they were in a good condition, fill point were away from the dispenser, they were 6 meters away from the building, overfill fill devices were fitted, sand pit was provided as a measure to contain control spillage, height of vent pipe was over 5 meters, vent were at safe location, vent pipe were in good condition, fill cap were provided. So the area of improvement they mentioned, So for all the areas, like for the dispensing, dispensing positive point were noted. The areas of the improvement were also mentioned. Like from the positive point, it was observed they were 6 meters from the occupied building. They were found in undamaged condition. They were provided with the safety barriers. Nozzles and hoses were in good condition. Volume time cutoff was provided. Dispenser hoses were fitted with a breakaway coupling. Sand bucket were provided. So then there was a certain area where the improvement was also recommended. Similarly, for the storage, the positive point were noted. Their area of improvement from the positive point, like the life was less than 15 years, all are like some with tanks, a double scheme construction, no indication of loss of containment. They were more than 30 meters away from the residential area. ATG was in automatic tank gauge was installed for leakage monitoring. Observation well to detect spillage movement into the ground water were provided. Pipe work, like positive point, the life was less than 15 years, no indication of the loss of containment. They were 30 meters away from the more residential accommodation. Then from the training point of view, positive point like firefighting training was provided, whereas from the area of the improvement, training needs to be required for the staff for the emergency shutdown procedure, vehicle collision procedure, safe loading procedure, spill management training, safe dispensing operating procedure, safety management maintenance procedure. The housekeeping point, there were some positive points, some are area of the improvement, like for the wastewater treatment facilities should not be outside, it should be away from the site. Water cache water segregated for treatment prior to disposal. Housekeeping these as from the environment point of view. The summary of the deficiencies, then costing and the time estimation for rectification of the deficiencies that was also carried out. The recommendations were provided based upon these findings with respect to the basic safety, like the water fire extinguisher should be provided to extinguish solid combustible fire. These include fire due to the wood, paper, solid plastics. Water fire extinguisher should be provided in a manager's room as well as in the storeroom. Emergency contact number should be displayed. Following measures to avoid the static electric fire cases should be adopted. Nobody should get in or out of the vehicle when the petrol is being poured in. Rubber-soled footwear and clothes of synthetic fiber should not be worn. Handbrake should be engaged. Then these are the recommendations for the offloading and the vending, like reversing the tanker can be difficult as well as dangerous. Therefore, forward exit paths must be made available for tanker. There should be a regular practice of isolating of dispensers during the offloading operation. Flame arrestor at the vent pipe should be provided in order to control any flame. In case of fire, fire extinguisher equipment should be provided in the vicinity to the tanker offloading. Lighting protectors should be installed. There are some recommendations for the dispenser, like there should be a distance of 10 meters between the two dispensing islands. Relocation of the dispensing island is recommendation. Clear routing rows. Arrows should be marked around the dispenser to manage incoming public traffic and to avoid any confusion or the vessel collision. Vehicle collision. The ground surface should be made of impervious material like, for example, paint, to ensure that there is no seepage in case of leakage. Then the storage should be logged, history should be made. Then the training should be provided for the people as we discussed. Then from the environmental point of view, like the car wash wastewater should be collected in a sump. We should not be drained in a sewerage system. Wastewater collection in the sump should be taken to some remote location. Car wash water should be segregated for the treatment prior to disposal. Periodic inspection of water tanks should be planned and performed. Similarly, engineering document, there whatever the document missing that should be prepared. The QAQC. The annual audit and NDT should be carried out as per the plan. The requirement of the CP system for the underground assets. Conclusion, like they were in like saying a satisfactory condition, but some corrective action arising which need to be carried out. The checklist was provided, and based on the checklist, some recommendations were mentioned. So, like this estimation and the optimization of the petrol station was also the part, like the adequacy of the number of the petrol station that was carried out based on the estimation and optimization of the petrol station, where the fuzzy logic is used to estimate and locate station, considering safety, land use, and road demand. The number estimation was done based on the petrol station optimization of station location. So, like this equation was used based on the demand of the petrol station, which is basically the sum of L1 TV1 and V, like which is the load index, vehicle type index, length of the road, amount of passing vehicle, in the way the amount of vehicle special fuel consumption for the type of V. So these are the some mathematic calculations that was done in order to determine the fuel demand, in order to determine the number of required petrol stations, effectiveness, like the factor which were used for the estimation, like the land using, safety, infrastructure, then the infrastructure like the electricity, telephony, transmission lines. Then from the road safety point of view, distance from the road, interactions, technical structure, distance from the big cities, distance from the township, residential and industrial region. So these are the different factors that were considered in order to estimate. Then from the land usage, either industrial, residential, agriculture, pasture and the plain lands. Then accordingly, with reference to the risk, they were their GPS position was checked and mentioned. So there are category was defined. The conclusion, the optimum number of petrol stations in the country should be 110. This is based on the overall risk ranking of the petrol station as per the HSE 0.46. That was the one suggestion was provided as the recommendation. The adequate number of petrol stations proposed by Velosi based on the observation. So these are the basically the observation, like which we already discussed. Their assessment as per APA, as per HSE 146, checklisting, there is record, risk assessment, then the comparison between the different risks. So these are basically all these, like first the offloading, allocation of the damage mechanism for the tank and the piping, which we discussed, like the thinning, corrosion and infiltration, microbiological, then their POF and COFSS. The risk was assigned, the inspection plan was provided, which type of the inspection to be carried out, like a visual inspection, any NDT and the ultrasonic thickness gauging, scanning, RT. Then from the dispenser, it was found that dispenser age greater than 10 years did not incorporate the breakaway coupling. It is recommended that regulatory should suggest a breakaway coupling of the standard make to be installed uniformly in all petrol stations. So these are, so similarly for offloading and venting, recommendation was provided that it is recommended that all fill points should be placed within a suitably covered subsurface pit to protect against the physical damage. For the storage tank, like the recommendation, this is a general layout issue and cannot be solved unless, so however, using insulation lid should be made mandatory as a best industry practice. Layout, there were 4 petrol stations which has emergency switch far away from the manned area. Mostly were located within the electrical switch room. This is a general layout issue and cannot be solved unless, because this is the design stage, renovation would be made in this petrol station. Necessary arrangement should be made to relocate the emergency switches to area which is manned 24/7 rather than in a remote area. The training, so that the training should be provided for the people. Inspection and the maintenance, so regulatory inspection should be carried out as per the inspection maintenance that was recommended with respect to their frequency. The report was prepared, like the executive summary, introduction, methodology, major findings. inspection and assessment report. So that's all. We basically know the time is there. There are the few questions. What we will do, if any a question which is if not addressed in the presentation, you can send us through the email. We will give you the answer. So now the time is there, 4 o'clock. And if any question which is not addressed in the presentation, that can be addressed. Thank you very much.